to this Leadership Forum panel in which we will be discussing, and let me read this to get it right, and I'll tell you why that is true in just a second. Software-defined everything, composable infrastructure for private clouds. Now, that's a bunch of buzzy words, and one of the things I want to do over the next hour or so is to dig into what that really means, dig into what's possible. And in order to do that, you can see the logos rained above me and this lovely array of intellects to my left. As I said, my name is Mark Peters. I'm a principal analyst at the Enterprise Strategy Group, a strategic consulting and analyst organization based out of Massachusetts, as you can tell from my accent. This is how everyone talks in Massachusetts. There you go. I've done it now. I'm actually based in Colorado, and it really is how everyone in Colorado speaks. Anyway, so we're going to talk about a number of buzzwordy areas, and I'll get to that in just a second. We'll probably touch on digital transformation. We'll touch on software-defined, as it says here, everything. But the first thing I want to do, and this is, I hope, the only time I have to do this, is to go down the line in order and allow each of you time to introduce yourselves, a little bit about your company, what you do, you know, a little bit, not your favorite color, but why you're interested in being on the panel and where the conversation might go, that sort of thing. I will refer to my handy-dandy cheat list so that I get all these titles right, because you have an impressive bunch of long titles. Okay, so first off, we have Chris Tinker, representing Hewlett-Packard Enterprise. If we say that once, if we mistakenly say HP, we're okay after 10 minutes or so.
Absolutely.
Here at Chris, it says Chief Technologist and Distinguished Technologist.
Yes, I came out of the lab after about 17 years as a distinguished technologist for Hewlett-Packard. This is called a smoke jumper, a debugger. Then I brought those skill sets into essentially what we're doing in our software-defined ecosystem, the composable ecosystem of HPE. So we're looking at taking our technologies and evolving how we go to market. So that evolved into a chief technologist role for North America, where I work with our collaborative product development groups to bring in various technologies that augment our portfolio. And of course, you see here, the panel here is made up of just such technologies. These are disruptive technologies that are actually delivering business outcomes and business values for our customers in an ever-accelerating market.
Okay, thank you. And it's fascinating to me because you threw in another term there, which I know is one that HPE likes to use, of composable.
Sure.
We don't need to dig into it now, but as we talk about this in the group, I do think there is, you know, a sort of spoiler alert for my first question, talking about what all these different terms mean, and are they really all just, can you have 5 sides of the same coin? No, but we'll talk about it in any case. All right, next, as we go down the line, we have Trevor Calder, Principal Technologist, OEM Sales, Mellanox, yes?
Yes, so I work closely with HPE and a lot of the partners here, and what our team does at Mellanox is focusing on taking the fabric to enable data center compute scale. So not just within the CPU, within the switching elements or the storage, but across the whole data center. So that's where our focus is today and going forward.
All right. J.R. Rivers?
That's me.
Yes, and if we look at the logo, I can work it out here, see, so CTO of Cumulus.
I am co-founder, CTO at Cumulus Networks. We kind of recognize the advent of what I would call kind of this information IT-oriented economy and age right now, and recognize that network infrastructure as we used to know it, which is kind of composed of closed systems, was going to eventually evolve into a more open systems approach, and we started a company that provide a network operating system as well as operational software to help people build massively scalable networks with the right feature set and the right cost, both capital and operational costs, to meet their business needs.
Thank you. Chris Cummings, looking very dapper, I have to say. Yeah.
Very dapper.
Didn't get the memo, obviously.
He got voted best suit on the panel.
He got I like that. Yeah. Okay, so Chris, CMO Datera, yes?
Chris Cummings, and I'm responsible for go-to-market for Datera, and really pleased to have everyone come together and work on this topic, because we're working on it every day out in the marketplace. We're working on it with customers, and this is our chance to talk about what we're seeing in the market. So looking forward to this.
Okay, and thank you for getting everyone together. I do think getting a mixed group of people, sorry, I'm sure you're a mixed group of people, you know what I mean.
Technology.
People that represent a mixed group of vendors, attitudes, approaches, although we may find as we go through this that there's some level of congruence in terms of where the world is going. Scality next. I hope I don't mess up your name. Greg DeFreya?
That's perfect.
For an
good.
Englishman, this is
That's
really good because I
fantastic.
feel like I'm speaking a foreign language there. So, okay, all right. And Field CTO of the Global Technology Office, correct?
Correct.
Okay.
So Scality has been a longtime partner of HPE. HPE, we're actually part of the Pathfinder program, and Pathfinder is when HPE becomes a strategic investor in the company. We've had a long-standing relationship, many customers in the channel, and we focus on scale, file, and object, and we're software-defined on Apollo hardware. We're working with customers on how to transform traditional workloads, so things like monolith systems, but we're also doing a lot on the innovation side, digital transformation, edge core cloud, multi and hybrid cloud deliverables for customers. So, in our partnership with HPE, I think we have a unique opportunity where we're helping solve a lot of traditional challenges around scale and growth and cost, but we're also providing that path to cloud, which is extremely unique in the market.
Thank you. And those following along at home can see it says WekaIO there. Matt Gruen is Senior Director Channels. Did I get that roughly right?
That's roughly right. So
Okay.
yeah, I'm responsible for our channel and go-to-market at WekaIO, as well as our HPE relationship. And I'm a former HPE employee and really excited to be talking with HPE in that context. WekaIO is the world's fastest file system, and we've been able, in a software-defined platform, to provide a file store that meets the needs of some of the new applications. There used to be a lot of focus on protection and functionality and scale, but also now performance really comes into play into some workloads that we'll talk about. And again, we're excited to be one of the newest Pathfinder companies at HPE, and excited about the way HPE does bring all these groups together, these varied and disparate organizations, to provide their customers a complete portfolio.
All right, well, thank you all. I'm not going to say you can never talk about your companies and what you do, because you will all want to. We'll try and keep the pitching to a reasonable level, shall we say that? Certainly no sermonizing. Okay. And please, one of the things we also discussed is chime in. My job, hopefully, is to control, not cajole, if that makes any sense. And having met you all now, I think it might be a big job, but it won't be hard to get you to talk.
I resemble that remark.
I know. Let's start with, if you like, at the highest level, not philosophical. In fact, by definition, I want to get under the words, under the semantics, into what it all really means. I threw out a bunch of terms, and I'm going to address this to whoever wants to chime in first, but whether we're talking about software-defined X, private clouds, we're talking about flexibility, we're talking about data transformation, a whole host of terms. Are these all just talking about the same thing of finally getting our act together? I'll start down the end since you're nodding, but I mean, are we finally getting our act together and talking about workloads and managing IT for a purpose, not just because it's difficult to bolt it together?
I really think software-defined provides the opportunity, and it's been something that we're now progressing to the point where we can get there, right, in terms of the capabilities in the servers, both the hardware, the software stacks, that we can adapt to those workloads and to those needs. So if you look at the products here or the products in the software-defined space, to me, that's what really we're talking about. Now, customers can more easily control, compose their solutions. And I'm very excited about the prospects for what that can bring. I think the pace of change has been, there's Moore's Law in many respects and in many areas, and one of them is certainly in the pace of change in IT, and it's continuing to pick up, and software-defined is a natural extension.
No, I would second
Good.
that.
Three of you at once.
But
We'll start here, then Chris, and then JR. Okay.
I second what Matt has to say here. I mean, if you look at the ecosystem, customers are wanting outcomes sooner rather than later, and they're wanting to consume it in a way that's simpler. So if you think about, like, even with HPE, right, our strategy is make it simple, have the expertise to make it happen, and empower the intelligent edge. Now, all that said, we can't do everything. it is reliant upon us to figure out, okay, this technology's got to run on something. It's got to be optimized to run on that. So we have to have a density of utilization, the effective utilization of the assets, but you also have to have northbound, southbound APIs to do a software-defined control ecosystem. And all of that said, it really comes down to swim lanes of various workloads, and those workloads require specialty software stacks that actually deliver those outcomes. And those specialty software stacks require HP as a strategic entity in this point, is figuring out what technologies essentially bolt on or work with our technology, then collaborate together to bring that to market so we can actually accelerate the value to our customers.
Chris?
It's challenging, I think, because when you talk about software defined, and we deal with this every day, and we all talk to customers every day, there is a soup of terms that are used for a lot of the same exact stuff.
Sure.
Whether it's composable, or people are talking clouds, they're not sure which cloud we're talking about. Is it hybrid? Is it multi? Is it public? Which?
We
you
could have
could
an
go-
hour on what do you mean by
Right,
hybrid.
you could
but
go
anyway.
on and on,
Right.
but I think at the end of the day, what we see is amongst all of us, and the reason why we're working together is we see these customers coming and say, I want to architect it differently, I want to consume it differently, like what Chris is talking about, I want to pay for it differently, and I want to operate it differently. And when you look at what's coming together amongst this crowd here, it's at a scale that's unprecedented right now.
Agreed.
And so that means that
Scale of
it's
change and cooperation, or scale of ability?
well, nicely done. I think you can just keep going.
Yeah.
But
Yeah,
in terms
agreed.
of scale, I mean, if you just think size, you've got to be able to run this in an automated fashion because you just can't throw bodies at it the way that perhaps we used to in IT. And so that's what's a common thread, I mean, I think among all this, where software defined and automation, those terms to me go hand in hand because you can't really get there without them both together.
I'm going to half agree with you and half disagree with you, just
Okay.
for grid. So when I look at software defined, to me it's so clearly two different pieces. One of them is actually really easy, which I think we'll all agree with, is that open systems trump closed systems. When you have open hardware systems, you can always choose what you're going to run on them and how they're going to behave. And so I'd imagine everybody here runs their software on open systems right now, and we see more and more customers taking that path. And part of the reason why that matters is because the days of IBM coming in and solving all of your IT problems with their hardware and software have been gone for a very long time. People make huge investments in things like fast file systems or really great network inspection software or intrusion detection systems or whatever, and building the hardware that goes along with that and integrating that hardware into complex hardware-oriented systems doesn't scale just from an ecosystem building perspective. So keeping those things soft and running them on open systems is phenomenally empowering. Yeah. The second part of software defined is recognizing that you can, with the premise of scale out infrastructure, you don't necessarily have to have any one element be as fast or as performant as humanly possible. It just has to be as fast as necessary, kind of for its point purpose, and have the ability to scale.
Right.
And I worked at Google for a reasonable amount of time, and what you recognize is some of that stuff was not necessarily the most efficient. And so software defined kind of gives you those two dimensions to work with, and where all of a sudden someone can work on best in class, 5G, signal processing system that runs as virtual machines or containers. But because it's a virtual machine or container, it can run on any infrastructure that you stand up.
Right.
So I think one of the things that I'm hearing here is that you need to be agile, and whether you can call it whatever you want, but you got to have the ability to move between workloads, move between different instruction sets, move between different customers, and you need to be able to scale from small to large. What the open systems do for us, giving us those properties, they also invite intrusion. So along with that, the software and the hardware need to be in lockstep so that we're creating isolated systems between the CPU and the networks, between the storage and the VMs, or Kubernetes coming into play. We need to have all those working in lockstep so that we can make sure that everyone's secure, and at the end of the day, giving the customer what they really need.
Sorry, no, go
Well,
on.
there's a lot of validation to this also. At the end of the day, it's just not, you just can't throw these things together, right? These are enterprise markets we're going into. These are enterprise customers. They're having to deliver a particular service to their end user, their end customer, and therefore there's a level of expectations around reliability, durability, data protection, sovereignty, all this other mess we talk about. At the end of the day, though, you have to create these interoperabilities, certifications, tests, and the rigor that goes into, even though it's software defined on commodity or open systems, there's still the test and development and QA that must go into it, like the enterprise workflows, those test patterns.
And the support.
Support, yes. Yeah.
Well, there's some literature out there that says customers want open systems, or they want it software defined, totally open. I want the flexibility, I want the economics associated. But by the way, what do you develop on? And maybe could we just sell it on there? So there is that advantage because they have to produce. And at the end of the day, everything we do is about solving a business problem. And part of that problem should not be the technology failed.
Sure, many of us worked in the appliance business at one point in times in our career, and there's a lot of sense to that. They want all that, like what Matt said, but we want the simplicity too. And I think that's really where this has to evolve to as we move down the path.
But I think if you look at the operating model with a lot of the enterprises, they're used to managing in that fashion. However, the requirements are shifting. The lines of business are asking for new digital products that have a different requirement on infrastructure.
Well, Greg,
They're
you said it right. The business leadership, they're wanting a time to market. They're running their credit card. They want it faster.
Yeah, they want an instant gratification, but these workloads are highly distributed, highly scalable. They're often the digital experience to their end user, and not only are they looking to store it, they actually need to drive value out of the data.
Right, but isn't
So,
this?
you know, that. So to me, like I think it's it's interesting with our partnership is, we play a lot in the data center, but we're now working a lot more with the app architects lines of business, and that pain is different. That's a different pain to manage and architect for. And this is when I look at the panel up here, I look at the products and the solutions that we have, and a lot of them actually work very well together. Is that these are the ingredients that are going to power that next-gen digital transformation. So, and I think we have a really good partnership in order to execute that journey.
But this kind of gets back to the private cloud part you were bringing up earlier, right? Where, again, having worked at or with some of the largest people in the world, what you recognize is they don't architect the infrastructure for an application at any one moment in time. What they do is they take into account all the applications that they run on the infrastructure. They architect this year's infrastructure. They go out, they start building it. That architecture will run between a year and a half. And a year and a half later, they will have a new architecture for the infrastructure that's based on whatever applications we're running and have come over the last year. So they build infrastructure not for any one application or group of applications or business unit IT. That's all Wall Street IT. Nobody can do that anymore. It's not scalable.
Lifecycle management has collapsed.
Exactly. So what you have to do is you have to say, okay, this is what we know today. These are the set of things we're going to bring together. As you were pointing out, we have to QA them, we have to test them, we have to deliver them to our businesses. And we have to recognize that life cycle of that thing is no more than 3 years. And we're going to, we'll do one version of this, a year and a half later we'll do another version, and then the third year we'll come back and rip that stuff up because there's better hardware, better software, and we'll do it again.
It's a granulation of control, a granulation of the assets being utilized on that. You're absolutely right. It just goes into a granulation of scale because it is a large scale, but what he's referring to there is the granulation of those life cycles. The compartmentalization software-defined allows us to be a little bit more flexible.
So, you finish your thought and then I'll chime in.
No, chime in.
So, sometimes, like most people, and you're all the smart people on the panel, so I'm allowed to say, I like to sound cute or funny. Originally when software-defined came out as a term, I would say, well, show me something that isn't software-defined, and I'll show you some metal, some plastic, and some sand, because everything is. But I've thought more about it. No, but I've thought more about it since, and the key word is definition.
Right.
Whether that's for a swim lane in your term or for whatever the application of the moment is in yours. But the question for all of you as representatives of the industry, deliberately being challenging, is have you done a bad job? Are you using too many terms? Do you think people really understand software-defined and what? Because I think of all the terms we use, whether it is creating a private cloud, whether it is composable, whether it is digital transformation, many of them come back, at least my opinion, I'm putting it out for discussion, to some level of software-defined capability. Are you
Absolutely.
failing yourselves? I mean, it's good that you're getting together and talking about it here, but are there too many terms?
Well, I'll date myself a little bit on this one, which is this is my 5th go with Datera. This is my 5th go at software defined,
Okay.
and at multiple different vendors during the time. And some of them were true to form, which is what we're trying to do, and I really think that these folks and this panel, we are trying to do it true to form. Some of them were abject bastardizations of the term just to be self-serving. I'll just say it out loud. I mean, it's the fact. That's what vendors do.
Don't go on LinkedIn and look them up.
Yeah, go ahead. But I think the difference is that, like you say, what is it that you're trying to achieve? And we are trying to get to a level of being able to abstract out a lot of the logic that we had custom built into these systems, take it up so that it is tweakable, so that you can start it at the application and work your way down, and then so that once you're at the application and you feel like you're good, you've got an app that's coming up and then it's leaving, okay, well, guess what? If that app changes and the requirements therefore change, I've got to be able to change it like that, not by wheeling in new stuff. I've got to be able to make those changes. That's really what software defined is. My impression is we lived through the hype cycle. This thing was way overhyped as a category. We rode up to the height of inflated expectations and down into the trough of disillusionment. But we have a bunch of vendors that are really making the way back out. And I think that's the nature of the conversation that I think we're having with the market now. Is it's changing, and there's a much better ability to deliver against the requirements that had been there from the onset, but weren't achieved back then.
One thing that we got to note, it was overly hyped, I agree. But was the hardware there 5, 10 years ago when the hype started? It really wasn't. So today, a lot of people are still at 10 gig, but you could do 200 gig Ethernet. You couldn't do that 6 months ago, right? And 400 gig is 12 months from now, right? So the economies of scale are just going crazy. And then inside the server, the spindles for your storage guys have changed drastically. So I think the technology...
There are no spindles. It's all,
exactly,
it's all
they're gone.
Flash, right?
Boy,
You're old, dude. You're really old.
Someone want to bring up tape now, okay?
So with those
tape?
things, maturing and enabling software-defined everything, I think that's really allowed it to come to fruition.
Yeah, I think there's a catalyst there because the software-defined evolution, it's also brought about the acceleration of hardware to essentially deliver outcomes for that software.
Absolutely.
If you think about what he just mentioned, 200 gig Ethernet, most people out there would never even thought about that. And of course, in the HPC world, when customers are doing data analytics, well, is that over a terabyte, a petabyte? Hundreds of petabytes. So if having these discussions around what is the amount of data that we're having to analyze against. The paradigm is shifting, but what we're really seeing out of this in that software-defined ecosystem is lifecycle management, as you alluded to there. We talked about I'll call them swim lanes because there's technologies that are surgical in nature that deliver, like Weka, for example, high-performing file systems for applications that need a POSIX namespace. All of this needs plumbing. That plumbing needs to have an agility aspect to it. With the networking. So you can always see these various things where maybe it's a Datera with a block solution showing customers how we can actually take a traditional stack, modernize it, produce a way of consuming it that is a cloud-like experience on site. This is what our customers are asking for. The question becomes, how do we deliver it? And how do we give them an enterprise experience that they're accustomed to of the years gone by?
Right. But there's a bit there that's related. I'm going to circle back to hardware and then customer perspective, which is, I mean, to your point, I think like any of these things, there's the people that are willing to kind of break their necks to get there, and there's other people that are going to wait and see what happens on the outcome, right? If you look at it, when we started Cumulus, it was like 2010. Every company in the world was running especially the biggest companies, were running their networks based on hardware from Cisco. And Cisco had no incentive to drive everybody towards 200 gig, right? People like Mellanox that are into, like, they sell, at their core, they sell switching silicon and NICs and stuff like that. It's all about high-speed components that people can build phenomenal networks out of. When you have people like that driving their ecosystem, trying to figure out how they thrive and strive, they start taking away from someone like Cisco that wants to kind of have a very appliance, closed-form solution. and give people access to hardware that's just incredible. The same thing's true of storage. We talked about spindles versus flash. The CPU subsystems and buses are phenomenally fast. That hardware evolution is what starts to allow the premise of software to actually work. But then you guys, all of you, except for me, I'm a networking guy, but you guys are all storage people. Dude, fiber channel used to rule the earth, right? I mean, the customer was never going to put there's magically cool whatever workload on non-fiber channel storage.
Right.
Those days, they're starting to be, I mean, still exist.
They're still
Fiber
here.
channel will probably never die, but people are starting to get more and more comfortable with like just network attached storage and Ethernet-oriented file systems, whether it's kind of RDMA over Ethernet kind of things, or even just standard network file systems. But it's that customer perception coupled with phenomenal hardware and open hardware, I think, that really starts to allow software-defined to really take hold.
And I'll take it one step further, which is I think we, as an industry, did a horrible job, right, with software-defined early days. Any application, any program we can do, that must be great. It doesn't run at all. It doesn't get any kind of realistic performance, but there it is. I'd like us to drop the term, right? We're the world's fastest file system. We don't say we're the world's fastest software-defined file system, and a customer doesn't care how we're getting it. There could be a rat in the back with the wheel going.
They don't care. They want the value.
How do we get that? How do we get that functionality, that performance, the protection, all those things?
Sure.
So.
Well, to some extent, and now I'm going to use a phrase that we can all, you can all throw up on immediately, but I mean, that was why I started where I started, with all these different phrases about, here comes that phrase, next generation IT. Well, thank you. But because it's an awful phrase. I mean, tomorrow's technology today.
And tomorrow they'll have next generation IT,
know,
which
I
is
know,
tomorrow's
right.
sector.
Where's that next
They're a day late.
generation?
Well, it's like the Jetsons are kind of flying in and drop, something on us. But just coming back to one of the questions, but I think that's what all this is about. I mean, and maybe you're right. I mean, maybe there's either a bad use of phrasing or too many phrases. All that said, a few of you have mentioned, and I just want to come back to this and drill. So what changed? What made this realistic now? We'll talk about how realistic. You get first answer, sir, but was it hardware? Was it something else?
To me, it's the customer, and they had a challenge and a pain that we'll call it software deployed on x86 solves for. Is that we're starting to see a lot of customers saying, I want to standardize on builds of hardware, put software persona on it, for storage, for network, et cetera, performant, capacity-driven workloads, and drive that through automation. And I think because customers are doubling every 2 years, we have this big digital transformation wave that is, if you look at the growth in digital transformation workloads, that's 10x over what they are currently managing today, which is doubling every 2 years, is the current operating model has to evolve and has to change, because I can speak for the customers I talk to, they're not doubling or tripling their IT staff. And when you look at execution on digital transformation is, if IT doesn't execute, the business suffers. So there's tremendous pressure that they have. So in order for them to execute, they need this technology in order to do that. And I think if you look years before, and I can look in my past as well, as when you looked at software defined, it was a little bit like, I run it as a VM, I do some things and get cute with it. Was it really meant to be deployed that way, or is it to check a box? And I think, early days, I think that was probably a box check, but now is customers legitimately have to run 7x24, X9s of durability and availability, enterprise grade, and the pain is so large that, I think it forced the market to evolve.
It's also the who it is. So on the enterprise side, like you say, they're forced to keep up with more and more. Listen, I'd love to have a development organization the size of Goldman Sachs, 5,000 developers. That's not every enterprise IT organization out there. And JR, you brought up Google and said, here's Google building from the ground up. This is the way that this data center and this whole data operation need to be built. So you have on one side the public cloud proving that it can be done, and then you have on the enterprise side, oh, I see the proof, and yet I need some of those same outcomes for my own environment, but I've got to be able to control it for whatever reason, whether it's I need the control of it because I'm a control freak or because I'm a German organization and I've got to have it live within my boundaries and I'm not allowed to use the cloud, whatever it may be. Or I need the performance dimension to it because I'm running a block workload and I can't yet get that out of the public cloud. Right. Whatever it was, there was the proof point. And now these organizations that have adopted and experienced it, they're not going to go back. They got to go forward, and that's where we have to come together to enable that.
Mm-hmm.
Yep. I see it as really, it's been a 20-year problem. So 20 years ago when we got started, we decided to go all in with mutual customers on InfiniBand. And that's where we started. And we kind of ran into some economics problems. The stock market crashes, people pull back funding, and we got to figure out where to put this thing. And Dr. D.K. Panda at Ohio State said, let's build a cluster. And at that point, 10 years later, the biggest supercomputers in the world are doing distributed computing instead of running on large iron. And the folks at Google and other very smart people out of Stanford said, why don't we do this on Ethernet and call it the cloud? Mm-hmm. And what they enabled is economies of scale, where we all had to your point, is catch up. It challenged us to bring native performance to VMs, like networking performance. And then we said, well, to get past the closed system on the networking side, we need people like them to come up with open systems that can run on top of this hardware.
And so it's snowballing, if you think about it, because
we're running downhill now.
Customers think about the analytics. The customers are getting smarter. Their businesses are getting smarter. The business guys are now looking at this mound of data they've gathered and collected, and they're like, what insights, what unfound treasure lies there? How do I monetize this? Mm-hmm. Now, and that varies wildly based on verticals and healthcare business, whatever. It doesn't matter right now. This data is growing by leaps and bounds. Mm-hmm. They want to be able to tap that data, be able to understand, what is the analytics that's going to run on it. So we have a new age of, I'll call them the analytic engineers that are coming out of school, coming out of college, going into the marketplace. And these companies now are hiring data scientists, which was, 5 years ago, you might have, maybe 10 or 20. Today, the number of data scientists are quite numerous. And these companies are saying, look, I need these guys. These guys have huge salaries. They're amazing talent, but the actual ROI on that investment, you need infrastructure. It's not just infrastructure. You need the software, the actual data on top of it, the actual analytics, the control planes, the consumption-based models. You need all of that to deliver the outcome. Because at the end of the day, they're just trying to do the analysis to deliver a business outcome.
But I would say that on the analytics side is, we've got analytic, which is, I would say is typically within a short range. Now we're seeing the emergence of AI and ML, which is a much different paradigm. It's actually the opposite of that workload, where they're combing through all of the data and trying to learn and improve business processes.
Sure.
How do they do things around quality of service and other things for their end users? So is that we've got this mountain of data, and there's, I might have a small part of it that's really HPC-centric for analytic. But now it's, well, we want to consistently mill through, which actually changes the paradigm of service that needs to be provided back to the application team. So we're seeing all these different things in us as a provider. I mean, we need to be flexible and agile to align to those workloads demands based on when those arise and how they want to leverage the data. And I think those are things, from an architecture perspective at Scality, is that we've got design principles specific around multi-site and geo, but also capacity and performant independent. And on top of that, not to make it even more complex, is I get this question all the time is, cloud's coming, so how do you actually extend services into the public cloud in a multi and a hybrid way in a very simplistic, consumable offering that has no lock-in? And I think just from an offering perspective, we've innovated extremely well in that area. But we're starting to see more and more the buying criteria is, yes, this is great that you're doing in the data center. How do you branch or help me in that hybrid or multi-cloud solution, which is just another set of parameters and challenges that customers need help navigating through.
But it's been this large evolution, right?
Sure.
Early in my career, I worked at Sun Microsystems. The network is the computer, right? The network. Thank you, network. So the network had to pull it up to get where the cloud, where a lot of what we all do in a high performance and a high scale kind of way makes sense. The compute technologies, the virtualization, containerization, I mean, all those pieces, it all plays together and it keeps building. And as you said now, artificial intelligence, we're going to try to mimic, you know, the human brain at some point. And to do that, the processing power and scale, again, comes to another level. And our customers, our collective customers have to work with that. You know, maybe they're customers in the data center. How do I service these data scientists that Chris talked about? How do I make them get satisfied with what they're doing, and then at the same time satisfy my business users who want that stability, you know, for the data that's going across our networks and our storage.
You know, I think it was, I want to shift gears a little to talk about the value to the customer. We've touched on it, but I want to drill into that a little bit. And it's fascinating. I know you won't believe I'm quite old. Okay, you believe. But what's fascinating is I don't know when, if you were to put a stick in the ground and say, when did the IT industry start? I mean, we could have a great philosophical debate and go back to the abacus, but let's say it was in the 1950s, realistically.
Pre-Al Gore.
Okay.
No.
Wow, no. Come
It was
on.
born on the same day as the internet.
What's fascinating, maybe for some of you, I won't pick on you, but myself, I've been around it for 30 plus years. That's half the industry's lifetime. And so sometimes it's interesting to think about that and say, it's no wonder that we're really only just getting to a sensible place. Now, I know we'll probably look back in 20 years and think today is weirdly inept, but the principle, I think, applies that we're now focusing on IT as it was supposed to be, information technology, rather than spending our lives worrying about the infrastructure, because the infrastructure, I don't mean it can completely take care of itself, but it can be subsumed to the application swim lanes to put some things together. What I wanted to ask about, we had a different panel earlier on and we spent quite a lot of time talking about complexity. So to save just regurgitating all that, the quick answer was we figured that complexity isn't necessarily bad. Certainly being complicated and getting, well, complexity can be good if it's used for good purpose. So the question for all of you is, what do customers get out of this? If you're just adding complexity for complexity's sake, even by adding something that's simple, because it's going to have more steps, you know, have you really gained anything? So what does this software-defined endeavor
I think it gives you
by customers?
two aspects, in my opinion, anyway. Is it more complex? That's opening up the hood and looking at the engine. Let's just close the hood. It's user experience, right? So that's one of the key things. The user experience, to give a better user experience, is going to require more complexity under the hood. But user experience is one. And then, of course, you've got the business value. And that value comes in the ability to, you know, it goes back to 20, 30 years ago, 10 years ago, sweating assets. And sweating the assets for an IT, for a business owner like a CIO or a business leader, they want to know, look, your infrastructure was consumed to X, 50%, 80%, name your favorite. The idea behind this ecosystem is, yes, it's more complex, but it's more intelligent. And it's more intelligent, therefore mitigating risk, creating better durability, reliability, and it goes back into like copy data management functionalities. But all this has to require plumbing. So again, we come back to its user experience, and it allows a business owner to gain more value out of the assets that they're acquiring.
Yeah, I totally agree with what Chris is saying, and I think we're kind of one of the plumbers out there. Is we need to provide to these open systems the hooks to see what's going on inside the fabric, if you want to call it that, or an adapter or a switch, so that the user can make use of that information. No longer are we just talking about the workload. The user actually wants to know what's going on in the network, because that might dictate the performance or what they're going to do 5 minutes from now.
For infrastructure, that's the telemetry to go back up to a decision engine, right? That decision engine saying what workload goes where and how it gets placed and all that mess. But at the end of the day, that's in a rules engine place. But that rule engine requires telemetry, the API, northbound, southbound, but also the KPI.
But I mean, to be super contrarian here, I'm going to point out that with scale comes chaos, and humans, for the history of engineering technology, believe that they can out-engineer nature. And my experience is they can't. It fails every single time. Many of you were around for the ATM days, or the fiber channel days, or the token ring. These were phenomenally well-engineered systems. These are like the smartest people in the whole world figuring out how they can make the world work perfectly, but yet Ethernet won. Ethernet won because in a chaotic environment where you don't like ATM phenomenal. If you can control everything and make it work just this way, ATM is by far the best.
There's still
However,
customers running it. So.
Yeah, very few.
Very few.
And most of them are running ATM over Ethernet.
Probably so. Probably so.
Right, so, but Ethernet, one, because it's a chaotic technology, you can put it together. It has a set of, the primitives are clear, they're easy to understand, they're transparent, and so people can create large systems out of reasonably simple, transparent building blocks that can handle phenomenal amounts of both complexity at scale and chaos, and deliver simple operating principles to their consumers. I will point out, Google, AWS, Amazon, AWS, Amazon, wow.
If you liked AWS, you might like
Amazon, right? Yeah. Azure, and if you look at the underlying infrastructure for all of these things, they're all actually reasonably simple under the covers. They're not like we read about these really cool things you might be able to do with all these reactionary engines and blah blah. They don't do any of that. They do maybe a little tiny bit of it. What they do is have really simple, transparent building blocks that work at scale in a super predictable way. Their failure characteristics are well understood, and they don't fail that often. And they roll them out, and they scale out. And that's what the history of our industry is doing. And part of what all of the people here do is actually help enable that. They help enable these reasonably simple, here's a really fast file system. Okay, cool, I'm going to put that in my system. I know what to expect out of that. Yay. Right.
So ease,
But I
scale,
want
flexibility, that's what I'm...
And if you're going to get that in the user space or in the application space, and you're going to get to a new level of scale, then it raises the bar for the rest of us to say, okay, we've got to make this thing simpler. And you guys started down the path of, AI and ML. We went through the word soup before. Now we're in, I don't know. We're in the like just some crazy stew that we're making. But if you look at IT, they'll say the number one place that IT expects AI to pay off is in IT, not for a specific use case in a specific vertical. And I'm not saying those aren't valuable, because they're hugely valuable. But we've got to be able to tap all the information that we are getting out of these systems to improve those lives, not just make a better alerting engine, but actually take action. So, and that's going to be best done not when we're just setting parameters and tripping alerts, but having the systems learn what's going on without, out in the fleet, bringing back the fleet analytics and taking actions. I need to move this workload from here to here. I need to replicate from this node to this node. I need to move from this data to this data center. That's where it gets the value of, we take that complexity out of the underlying infrastructure so that we can deliver the value up to the app and up to the user.
Isn't it all about layers, though? It's about layers of abstraction, and within those, then you take that complexity and you hide it, or you take the simplicity and build upon it. So in WekaIO's case, we've rewritten the networking stack, and we're using technologies that are now available, like SRIOV, that are supported on technologies like Mellanox's to make the network, make the data go faster and in a more purpose-built way. And that is a level of complexity. But then to JR's point, at the end of the day, the customer doesn't know it. The customer doesn't know that they might be running an HPE AI data node that has Scality and WekaIO together. They know they're accessing files really fast. And the fact that the scale's coming out of Scality and the speed out of WekaIO.
That's their transparent primitive, right? It's super predictable, fast file systems. I can get that.
I think that's true today. And going back to your point, the customer's becoming more intelligent. I mean, these technologists are brilliant scientists, right? And going back to my point earlier, that a lot of this comes out of technical computing. What are they doing in technical computing now in the fabric? They're doing computation as the data moves. We're not doing that in Ethernet today in the fabrics that we're doing software defined. But this is going to happen.
It is.
So 5 years from now, 2 years from now, well, you can pick a date, but it is going to become, the network is going to become more complex. So you're going to have to understand how to divide a workload, not only on a VM or a container, but through the fabric, through different switches, because every time it hits a switch, an operation's happening on that data. Because the machine learning guys don't want to wait for it to hit the storage in a CPU. They want to do something to it before it gets to the storage.
It comes down to complexity. It comes down to your perspective. At the end of the day, if as DTs, CTs, very technical bench here. So no, for these guys look
Why
at it
aren't
and go,
you waving at me?
no, it's not going to be.
Because you're the coach.
Yeah, right. It's not going to be a challenge for these guys. That's my takeaway here. Is this? This depends on your perspective.
All right, well, so shifting perspective, just a little bit to make it look like a segue, which isn't really, it's a sharp left turn. But we've done a really good job of talking about a lot of key buzzwords around the industry, both in terms of how we manage it. Of course, we've said cloud a whole bunch of times.
Yeah.
There is something that is top of mind to everyone in the industry right now that we haven't talked about, and I'd like to just see what the overlap or the implications are. Security. We do a whole bunch of research at ESG. I mean, there isn't anything, security is the #1 driver of spending right now. It is the #1 justification. It's top of the CIO whiteboard. In this general market, I know you're all representing different people. Are you making things tougher, or is there a route where this can link to reducing risk?
Well, from HP's perspective, again, collaborative product development. If you look at the umbrella of how we actually bring our ISV partners into the actual fold of HP and bring it to market, we look at our technology on the bench. What do we make? We make infrastructure, make a lot of it. That is being said, the most secure server on the planet is made by HP. The L380s, but at the end of the day, these guys run on that, right? They run on our servers. We also work with various other security implementations, whether it be the most secure server or whether we actually work with ISVs that actually do intrusion detection, or maybe it's data protection, data sovereignty. Those are just, again, looking at best of breed partnerships to come in to figure out how do we solve those type of problems.
So there's a great commercial out right now. I won't say the vendor, but they lead off with every intrusion over the last couple of years has started with a company that had a VPN and a firewall. And that's just not good enough anymore, right?
No.
So folks like HPE, they drive us as a hardware provider to put some hooks in there to, as low as just loading firmware, making sure that that's secure. But what you're going to see coming out over the next couple of years is on the smart NIC side, actual CPUs now inside the NIC. You'll be able to isolate between your workload running in the VM and the CPU and your network. And you'll have two different OSs that are completely decoupled, so nobody can come through the network and hit that VM. Mm-hmm. So that's the next thing that's on the horizon. And I think HP is well positioned to help enable our customers, our joint customers, to fulfill that need.
Yeah, security gives me a big headache. Because we hear about all this stuff. I mean, inevitably, some of it's pretty scary. It's phenomenally complex. Every time I study it, the answer seems to come back to most security breaches are actually human, not the cool stuff we think about on TV, but it's actually some human that goes in and does something and gives somebody
social engineering.
Social engineering, opens a hole, whatever. Hey, can you wire me $10,000? Or our CEO got the Amazon gift card one. Have you guys heard about that one? That's a great one. It's like they took a salesperson, they found a salesperson, they made the email look like it came from a salesperson, said, hey, can you send me 25 Amazon gift cards because I want to give them out to my customers, or can you approve this? And but that kind of stuff is, you look at that and you say, okay, no amount of technology gets you over that hump. So when I think about security, we provide, again, primitives that people can use to build a secure architecture. But inevitably, if you're going to build infrastructure and host applications on it, it's up to you to understand what your security, viewpoints are, what's open, where's your beachheads, how can people get in, what do you care about, what are you going to protect, who's doing it, is it the application doing it or is it the infrastructure doing it? And so as you go through that, you have to figure out how to use what primitives are available. No one's going to solve the whole problem for you. No offense, and nobody wants to hear this, but you're kind of on your own to figure out the solutions there. But each one of us will help in our own way.
Right.
Security is a tough piece too, because at one point in time, when you look at what we're dealing with when it comes down to managing the data after we are utilizing the network, we get the push me pull you of, I want security, but I also want performance too. And what's that encryption going to do to me? And for you guys that are, you're storing it for 7 years for various entities and much longer. When we're dealing with transactional data, SQL databases, and we start looking at encryption and then what happens with performance, that just raises the bar for us to say performance has to be not just raw performance. What can we do when we don't have any advanced services running on top? It's what's the performance, the actual usable performance that we're getting when we've got encryption, when we've got other things like compression, when we've got dedupe, we want to use all these services and not compromise ourselves when it comes to the performance. Otherwise, this is a system that's built for the last generation. It's not built for the present.
I think security is a tough one because I know when we talk to customers all the time, we get asked about features of security. Do you do encryption? Do you have access control parameters? And do you do things like event logging?
Multi-tenancy.
Yeah, secure multi-tenancy. Can you do physical and logical isolation? Ultimately, security is a big conversation. I think for us we try to flip the conversation as what are you trying to protect against? Because a lot of times encryption, if you have access, it does nothing.
Yep.
It's it's the padlock on the locker, but everybody's got the key. What types of situations are you trying to protect against? There is going to be the right offering that's going to adhere to those requirements more often than not. But I think when you talk customer to customer, these are not boilerplate standard things. Everybody's view and interpretation is different. And depending on legal counsel and other things that are happening at a business level I think when I look at it from a platform standpoint, we hook into a lot of the ecosystem, which is, I think, a very positive thing. Even like on the hardware side of the house with encryption and things that we've done with HPE, but also what customers already have in their environment and aligning to those principles that are there, not reinventing the wheel, having a siloed stack for this particular offering, but it's a big conversation. But I think ultimately we get asked about, do you do this? Do you do this feature? Do you do that? And it's, well, forget the features. Let's talk about what's the situation that you're trying to avoid.
Sure.
And let's engineer for that, because more often than not, with our ecosystem, we can handle those.
Well, and back to the prior conversation as well, which is this has to be tunable, because we're not back to workload, here's the stack for the workload,
Right.
on, off, whatever that may be. It's got to be, I've got multiple workloads running, I've got multiple tenants, whether they're applications or they're entities or organizations or groups within the organization. Okay, I've got to be able to have this thing turned on and turned off, but I've got to be able to do it at a macro level, not on an individual level. So that goes back to what's the definition of software defined? And it's really, how do I define service classes that allow people to tap in and take advantage of this, but not have it to be one size fits all. It's got to be everyone can tune for what they need for that particular environment, whether that comes to security or these advanced feature sets.
Yeah, I'd say, it also, we've talked about the evolution of the underlying platforms and technologies, and now, with the DL platform, that's got security built in. The CPUs have encryption offload devices. There's software. So as our customers have demanded of us to provide levels of security, and we provide those now. We just announced some today, in fact. We're taking advantage of those industry standard features to do it. It's also interesting to note that some of our customers who viewers might expect to have the most stringent security requirements, actually their security requirement is we've got a padlock and a concrete bunker, and so we're not running any on your technology. We're going to go as fast as we can.
Yeah,
So,
you got the perimeter aspect you're protecting. You got the on-premise.
But that's a good point, though, because we're getting asked a lot now is, I've got production. I actually want an offline, isolated copy somewhere that's not network connected
Air gap.
because they want that air gap. So we're starting to see that more often than not coming up now, saying, hey, we got this great distributed object store for a multitude of different use cases. We want that somewhere else, that someone physically unplugs the network every night and it synchronizes.
Protect, detect, restore.
Exactly.
And the ways you go about that vary wildly, but at the end of the day, it's bringing the right partnerships to solve a business problem.
But I'm pleased to hear you're all thinking about it. I mean, this is
That's
the
top of
reason.
mind.
Well, that's why I wanted to raise it, because it is top of the mind. Doesn't matter whether you know anything about IT. It's on the news. I mean,
When it's the top spend, it's top of mind.
Yeah.
Well, it's also the
helps
number
too.
one barrier to adopting a cloud approach, and cloud not being a place in the sky, but a cloud approach. It is the top barrier that's identified.
Obstacles to change.
Exactly.
The
So
obstacle to change would
we
be
have to
security.
deliver against that principle. Otherwise, we leave that particular customer to say, yeah, not for me. It's not ready yet.
And like some of the customers we're deploying in, they want to manage Linux. And they want to manage their kernel, and their security team wants to patch immediately. So actually, the alignment to us, like deploying in Linux on user space, actually is a really positive thing. So sometimes software-defined actually provides, it's a bad term, I know.
I know.
Sorry
Oh,
about
yeah,
that. I
you used it
slipped.
again.
I slipped.
Went back.
But in
Leveraging
essence,
open technology
open technology
gives them an
okay, we'll go
opportunity.
with it.
But it goes right back to that part of what I said earlier about the interoperability testing and validation for enterprise landscape. So it's a balancing act, and the various companies have gone and chose their own path in that. So it's, I almost said software-defined. But at the end of the day, looking
We
at these
can't
open
get to
systems.
the end of this and software-defined has become a
No.
bad thing.
It's a good thing.
Can
It's a
we?
good
I
thing.
mean,
No,
we're allowed to say
That
it.
which
We're allowed.
cannot be named.
What
Formerly
should we
known as
call it then?
software
Come on,
defined.
this is a good one for the panel.
It's software-defined.
Is that the catch-all for all those other
It's the
trendy?
catch-all.
No, I mean, again, I still think some of it's open systems. Like, there's a lot of the characteristics we talked about are enabled by open systems. Sure. A lot of, whether it's open hardware systems or open software systems, you know. So I think you can use software defined because it's software. Things can be upgraded very quickly. You know, I think the biggest part is looking at storage. There's a 3-letter bad word in the world that everything that they did was based on hardware systems. Like there was very little software on these things. Everything was built in FPGAs and ASICs and stuff like that. So the system had a reasonably fixed behavior with a little bit of dressing on the side. Everybody appears providing performance far in advance of that today, all using effectively software on x86 platforms, which makes it malleable and changeable and upgradable. So as a feature set or behavior comes online, these people can upgrade their products and deploy that in situ way faster than ever before. If they're using Linux, as Mark was saying, you can upgrade with the latest patch because the ecosystem is helping you get there. And that same CVE that's on your system is on every other system in the customer's data center. So their heads are completely aligned with yes, what it is, and B, did you solve it? So that transparency and understanding of simple primitives actually holds true there because you have those open systems.
I would be counsel for all of you. I mean, it's fascinating to get such a diverse group together. I really feel. I mean, I do a lot of panels, and you don't often get such a mix. I'm not suggesting you don't all have some degree of commonality of vision, but I would counsel that there's a phrase I use sometimes, the assumption gap. I don't know if I picked it up or made it up myself. Who cares? I've adopted it, which is that gap between the point at which something new comes along, and it's totally fine to ask about it all the time because everyone's asking about it. And then miraculously, I don't know quite how, you make this leap and you go into, well, I better not ask about it because everyone else seems to know. Well, I don't want to look stupid. Yeah. And I think to some degree that's where you are as an industry, as a group, where you've got to be careful. I would guarantee that someone watching us today will have learned something. And that's both good and bad. I mean, we don't want to bore people, but at the same time, what I'm saying is I think as an industry, if people are basing their knowledge and assumptions of that which cannot be spoken on the first time they came across it, when it wasn't really very mature, sometimes it was abused, that's not good. Whereas realistically, what this is all about is something bigger and more transformative. I don't want to. Oh, by the way, for all of you on the vendor side, there's a little bit of research that we do, and one of those is we track spending. What's fascinating, people who get into, now in this case, the term we tested was digital transformation, but again, we've agreed it's all in the same ballpark. People who attest to being mature in that arena, the degree to which they're increasing their budgets is about 3x that of people who are not. In other words, this is not one of those things that people get embroiled in because they can save money, be a little more efficient. Maybe they're more efficient, but it's to become better outcomes, right back to what you said at the beginning. And they can get more of it, so they want more of it, so they're investing. Anyway, so what should we call it? Come on, I want some answers. It can't be that which cannot
Hardware
be spoken.
decoupled.
Huh?
Hardware decoupled.
Wow.
How about that?
That sounds
I think JR is
they said it was a
winning
techie
the
panel,
argument
and now
on the way to describe it.
None of it's market
But
systems.
we do talk a little bit about getting away from sort of software defined. Sounds like it's almost an infrastructure way of defining
Yes,
it,
it
as
does,
opposed to we see out in the marketplace. We all see it, whether it's application centric. We see that from certain vendors. That's many vendors, or we begin to see service defined, which is what's the class of service I need by different application profile, and let me be able to start at one and know that I'm going to get it wrong, because JR, you started enumerating what are all the things that I need to know about this application in order to right-size this environment up front. If you went through that list, and we went through that list with our customers, they'd come back and say, I may know the answers to a third of those, and I would be hazarding a total wild guess to the other 2/3. Just get me started. So this whole notion of service defined, build it as you go, make it composable, and now we're back to buzzword bingo. That's what brings
I like the
out
idea of service defined, mainly because in my world, what I deal with is I work with a lot of these evolving technologies, and going out and meeting with our customers, and even internal in labs teaching the various technologies, is I find that when you say software-defined storage, for example, what is the swim lane? What is the categorization of storage? Is it performant block? Is it object? Is it file? Is it hyperconverged?
Yes.
You start looking at all these ecosystems. They're all amazing technologies that in their own right solve a critical business problem. But one thing can't do all things. And it's just being able to, so customers, I go and talk to a customer and go, I know I want software defined. What service do you want? What is the outcome you're seeking? Then the technologists can come together and say, okay, based on this requirement, based on this type of business outcome you're seeking, this would be the I call it the swim lane, but of course that's just my own tinkerization of it.
But
That's all right, Jeff
The
Moore would call it a bowling
tinkerization.
alley. It still works.
Hey,
It's
So
the
I-
same concept, same principle.
It's storage, it's networking, it's state-of-the-art. It's not next generation, it's state-of-the-art.
I like
State-of-the-art
to go.
storage.
And the art will continue to move forward.
Oh, gosh.
Yeah.
To your point, right?
But is it allowing you to somehow, it's not about recreating infrastructure in a different form. At least it might be under the covers, but that's not what you care about. You don't care about the compression engine in the third piston. You care about you care about how the car drives and where it gets
That's
you. and
probably the
what that
biggest
allows you to do.
evolution to this entire landscape. If you
But that's
think
where
about it,
service
years
defined-
ago it was about the box. It was about the widget. Today it's about the outcome. So
Well,
there's-
that's, I mean, that's got to keep throwing in here. I still say it's open systems, because if you didn't have a DL380 with a whole set
Agreed.
of well-expected behaviors, nobody else here could exist.
Yes, we wouldn't exist. That's correct.
Right.
Agreed.
And so that open ecosystem around the hardware allows a ton of different perspective on what services might be interesting to various customers, how you can go off and buy a single piece of infrastructure,
Sure.
that's reasonably well defined, and drop various services on top of it. All of the different storage profiles you talked about could all run. I guarantee you've deployed them all on the same piece of hardware, right?
Oh yeah,
yeah.
absolutely.
That's
Absolutely.
pretty arfing cool.
It is pretty cool. It is pretty cool. And then think about that.
That will be the soundbite from the entire session.
But
I
think
like
the
to go
tough-
back to what I led off with is we like to call it data center scale computing. And if you look at it from the CPU or the network or computational storage, it's all those things that Chris just mentioned. It can be 5 different types of storage, not just block, not just file, object. And as I mentioned earlier, you're going to start seeing computing happening in the network. So I think everyone here is I'm an arms dealer, we're an arms dealer, and I think we're all trying to enable the application. And whether that's measured in flops like it used to be for the computational side, or whatever the new metric is that customer, that workload needs, we're just going to continue to, every 18 months, enable this new architecture, the underlying architecture to evolve.
And
think
I
the
agree
other
with you.
thing is
Look,
on the,
yes, go on quickly, then we're going to have to wrap up. Go on.
Perfect. To me, where we talk to customers, I talk to line of business, application, enterprise architect, and then there's traditional IT. And I think a lot of the terms that we're talking about, the buzzword bingo, the way that we have to talk to those different personas is vastly different. Because the what's in it for them, or the pain that they're trying to solve, is vastly different. The outcome of the offering is, it's X hardware with X software-defined service running on it. But I think the hard part is when we're actually talking to an app architect, the way I talk about our software-defined offering and the APIs and the deliverable is much different. The thing I find interesting is that with IT's used to managing boxes or
Operations.
appliances, and they're going to continue to do so, and there's many workloads that work well in that. I think the working together with them is how do we enable them to adopt these technologies and kind of morph their operating model, because they're trying to support this, where the ball is going, and the car's going down the highway, they have to keep everything running, and then they have to transform as well, because the lines of business are asking for these new and innovative services.
And sometimes going around them and going right to the
No,
cloud provider.
Yeah, sometimes
Whoever.
like I feel like we're connecting the teams together where we'll go talk to the line of business. They're making infrastructure decisions and delivery decisions, and maybe they go right to public cloud because it's instant gratification. Sometimes we have to empower IT to say, this is the art of the possible, this is what we're doing, and this is why these folks actually care. So, can we be a change agent with you in the organization?
Well, that's it, and you do have to be solving organizational issues and challenges and opportunities. It can't just be about managing hardware, applications, anything by itself. I mean, very, very quickly, and then I'll ask each of you to do a 20, 30-second close. But I mean, if you think back to cars, I mean, people used to hand crank them.
Sure.
I know, it's true. And then, for years, people could do, your brother was talking about, you can tinker under the hood. I mean, these days, most people wouldn't go anywhere near any of that. And IT is similar in many respects, because now, again, you're not talking about necessarily getting in and fixing the car. It's more complex, but it has greater value. It's more reliable, and so on and so forth. As I say, just to wrap up here, I'd just be interested, the question, and I'll come down the panel. We're at Discover, so I'll let you go last, which is tough. But, should people watching this be running towards software-defined, whatever it's called, and why?
I think they need to. I think they need to look at what this newer technology offers in terms of their workloads, right? We, in our space, we talk with a lot of folks doing the artificial intelligence work that are working so much data and trying to crunch it so quickly. And they're seeing orders of magnitude improvement, one customer 2 weeks to 4 hours. They need to look at this and see, is there a way for this to make sense for their business? They're doing themselves a disservice. I mentioned at the beginning, I'm a channel chief. I talk to value-added resellers all day. I say, follow the GPUs, and if you're not following the accelerated computing devices and talking about our technology, that's shame on you. And I think for the viewers out there, they should look at, for each of these technologies, there's a unique value proposition that was enabled in an open system context. How do they make that happen?
So Scality is actually celebrating our 10-year anniversary this month. And we've built the company into a market leader in scale-out file and object to solve a problem. When we look at traditional IT workloads, is that we are commonly replacing traditional NAS and optimizing existing workloads around long-term archive and backup and others, big content-driven use cases. What we're finding is we're driving cost out 50, 60+% over business as usual, but at an increased service level. So for us is that there's a very simple on-ramp that many customers, that's kind of their first step is, I can optimize existing workloads around traditional storage, NAS offload, archive, remote office, branch office, long-term retention with backup. And we have very simple connectors into those environments. What we're seeing is that that's great, and we're doing a lot of great things there, and we've done some really good white papers around those use cases, is that where the ball is going, object storage is a pillar service in that stack. About 90% of that workload for next-gen and cloud-native applications is unstructured, and that's what we're maniacally focused to solve. So customers need limitless scalability, multi-site distributed architecture at massive scale at a low cost to serve. And we're doing that for many, many organizations. We're helping them through that journey. Is that, for customers that are looking to adopt, we're commonly leveraged as a tier of storage to drive out costs, and it's a very simple use case, and it's very plug and play, if you will. However, there's a lot of transformative elements that these next-gen distributed cloud-native workloads, analytic, big data, AI, and ML, they're going to need an object store as a pillar service in that stack. And it just really depends on where you are on that adoption scale. And some customers are way over here on the right on the innovation side. Others are way far behind, but whether it's traditional IT or monolith use cases or really distributed microservice use cases, we're in a position to help them with that unstructured data need. And some of the partners here, obviously with Weka, is we're doing things with Weka on HPC in those environments to basically eliminate a lot of the things around snapshots and RAID sets and traditional replication and backup, is that we're doing things in a different methodology that yields fantastic results, not only on service level, but also on cost to serve, and that's really where we're focused.
Okay.
So having lived,
That's a long 30 seconds. I let you go.
having lived in the object space before, I can see where that's kind of coming from. There was no way to do object in an array in any kind of economic way possible. You are the only way to get there, is doing it in a scale out on commodity servers. What we're doing is taking an approach of going after those tier 1 applications that in JR's, what JR referenced before, would have been fiber channel only, fiber channel forever, and saying there is a different way to do that. And in order to do that, it's not just driving costs out and saying, hey, we've got something cheaper, because Mark, you already addressed the fact that that's not the big motivator when it comes to IT these days. It's, yeah, okay, I can take costs out of the equation, but what costs? Is it infrastructure costs, or is it people costs? Because I've got to automate in order to get to a new level of scale. And that's really what we're doing for tier 1 block workloads, really for the first time. And so we have a big mountain to climb, but that's why we're working with and bringing together leaders like this, because we work with these folks on the hardware side and at the networking side. And at the end of the day, you're still going to have to protect all that data that's the SQL database. We can back that up and put that on a Scality. Sure. So it's, that's why we bring this all together.
JR, you're going to have something pithy, I know.
No, actually, I'm going to answer your question in 30 seconds. Okay. So my perspective, I have a very passionate perspective around infrastructure heroics. If you go through and study infrastructure and what's the definition of an infrastructure hero, it's about delivering the most compute capacity to your organization for the least amount of cost per unit of compute. It's the only thing that really matters. So you asked, do you run the software defined? You evaluate software defined, and if software defined is going to allow you to give the most compute capacity for the best cost per capacity, you should absolutely use it. I think nowadays, companies like Cumulus, companies like Scality, Weka, Datera, we all have gotten to the point where this technology is mature and it's absolutely worth evaluating. Today may not be your day, but I guarantee you 10 years from now, you will be using this technology or something like it in your world.
Agreed.
I'll save a little bit of time because I was going to answer the question like JR did. I would say you're going to be using this, so maybe not run to software defined, but I would run to an SA or an SE, because these guys have their fingers in it all day long, and they can help you evaluate which one of these solutions is going to give you what your customer really needs. And I think all of us together, we're in POCs together all the time. We're putting hardware out there, we're putting software out there, and these SAs and SEs are really the main guys that pull the customers in and make the eventual solution sale work for everybody. So I would run to them.
Going last is always toughest because it's like what they said, but maybe.
Yeah, it is what they said. Well, first off, it's the HPE Discover event this week. I hope you all are out there, get to take advantage of it, get to see what's on the floor, get to see what the customers have, the partners have. As you can see, we have a passionate group of partners, and the fact is that makes it very exciting. From an for an HP perspective, for our complete program, I just simply surmise it to say, business requirements, application requirements, technology requirements, and it works in that order. You figure out what the business requirements are, then you figure out what the application needs, then let's talk about what technology drives the outcome that you're seeking.
Thank you very much. Thank you to all of you for your insights, your enthusiasm. I think that was plenty of emotion, and hopefully those of you watching enjoyed it, and if nothing else, learned something. Thank you.
Thank you.
Thanks.
All right. Thanks, guys.